Hey, this is Dr. Guillemette coming at you with another video. So we're talking about confidence intervals for proportions, and my kids and I used to watch the first couple of seasons of Legends of Tomorrow, and so this is a picture of Gideon, and this is our problem setup, right? So Gideon, the AI aboard the Wave Rider, is analyzing Mic Rory. Mic Rory is Heat Wave. He's sort of an anti-hero on the show. Contributions to the team. She wants to determine the proportion of missions where Mick is actually helpful. Of the last 50 missions, Mick was helpful in 31 of them, and he just set stuff on fire in the other. So there is Heatwave, Mic Rory doing his thing, setting stuff on fire, right? So the objective here is we want to calculate a 95% confidence interval for proportion of missions where Mic Rory was helpful. Now, we're going to go to Jamovi, and I'm actually going to use the ESCI, the Estimation and Confidence Interval module, to help do the calculations. Remember, you can set up a free Jamovi account at jamovi.org and use their cloud-based service on almost any device. I am using the app. It will look exactly the same in the app, but I use the app on my desktop for stability, so I don't have to worry about an internet connection, right? So let us go ahead over there. Okay, so here I am in Jamovi, and I'm in the data tab, and then I've done two things here. I have helpful, and then I just in row 1 I put 31, and then I put 19. Okay, and I just type those in. So how often was Mic Rory helpful? Then I actually have this variable. This is the mission success, and helpful is considered a success, and not helpful is considered a failure. I guess I could put set on fire, and that would be the failure there, and you can see helpful and set on fire are here. And so what I did was I actually listed helpful 31 times, and then I put set on fire up to the sample size of 50. This is going to help us look at it in two different ways. Now, I do have some music effect data in here, but that is for later on. All right. So once we have our variables in, and most of the time it's going to be this summary data, but just in case you're looking at a survey and you have a list of data, the actual raw data is what we would call this. You can do it both ways. So I'm going to click on analyses. All right. Now, these are frequencies, and so I am going to click on the frequencies. I'm pretty sure frequencies is part of the base Jamovi. It's not a module. And so what we're going to do is we're going to click on the two outcomes, because that's what we have. We have two outcomes, helpful and not helpful, helpful, set on fire. So I click on the two outcomes, and so if I just have the values as counts, as I do have in helpful, as you'll notice, it thinks that the first level, 19, and there's only one of them, and that a level is 31, and there is just one of them. But what you can do is you can click on values are counts, okay? And what you'll have here is the proportion is 62%, and this is a p-value of if it's the proportion was equal to 50, and so that's over here, this p-value. So I have this proportion over here, but that's not what I want. What I want is the confidence interval, and I click on the confidence interval, and I get this 0.472 to 0.753. Okay, so that I want you to keep those in mind, right? So that was the if I just have, remember, helpful with 31 that are helpful and 19 set on fire, right? So now if I click on proportion again, I can swap out the helpful and I can put in mission success. But now I don't want values as counts. I have to turn that off. And now I have the same 47.2% and 75.3% for my proportion test. Okay, now that would be one way of doing it. All right, now the other way that you could do it is we can do it in our ESCI module. And again, to get the SCI module, we're going to click on plus modules. I'm going to click on the Jamovi library. I'm literally going to search the ESCI. That is the estimation statistics with confidence interval. It provides a frequentist and are based on the StatPsych package. And so we have that here. Right now I've already installed it, so I don't actually need it. So we're going to click on the ESCI, and we're going to go down to a single group of proportions, because that's what I have. I have a single group proportion, and so here it is. And so it wants the outcome level, and so I can actually go ahead and put out helpful and send it in, and you'll notice that it does the same thing. It's got this silliness right here, where we got level 1 and the 19, right? So what I need to do is I need to use the mission success. So let's go ahead and put that in, and there's the mission success. And wait a minute, this is 48-1 and 74-1. So that is not the same. Huh, interesting. Okay, so I'm going to come back to that, but I want you to notice that these are not the same. Now, what I can do is, I can't actually use helpful here, but there is this one up here. I can analyze my summary data, and I can do mission success, and then I can put helpful, and that helpful, there were 32 that were helpful, and let's see, was it 32 that were helpful? 31 and 19. All right, so let me go back to my 31, and we can do, now this one's set to not helpful. We're going to put the 19 in there, and there we go. So there is our confidence interval, right? So I can either analyze data with mission success, right? Or I can analyze it by plugging in the summary data. But again, I have this difference right here. So what is going on here? Well, let me click on the proportion test again. I have this Bayesian statistics. And what we can do is, if I click on the credible intervals, what happens is I have the 481 and the 481 here, and the 741 and 742 here. So you got a little bit of a rounding issue that is happening here. And so these are the same. So what are these credible intervals right here? Well, I'm really glad you asked. And so we're going to switch over to Excel and take a look at that. Okay, so we're here in Excel, and here's our 95% confidence interval. I had 31 successes. My sample size was 50. These things were all given. Now, this is my sample proportion. I'm literally just dividing. I'm calculating my standard error. I'm calculating this standard error using the Wald method, what we would call the Standard Wald method, and then there's my critical value. And so you can see I have this. Now, you're like, wait a minute, the Wald method? Well, it turns out that there are actually 5 different types of confidence intervals for proportions. So shout out, I'm going to leave a link to this article in the description. But Dr. Robert has gone through and written this article. I'm going to scroll down to the part. So the Wald interval is the one that we use a lot, okay, in an intro stats book. So here you've got the p-hat plus or minus the z-score, and then this standard error calculated with p-hat 1 minus p-hat all over n. So this would be the Wald confidence interval, and I get the 48.5 and the 7.55. This is probably what you're going to be putting into things like MyMathLab or Alex or any other system like that. So this would be the Wald confidence interval. It turns out that there's this thing called the Agresti-Coull, and it uses a small sample estimate or correction. And so what it does is it adds 2 to the successes, and it adds 4 to the overall sample size. So basically 2 more successes and 2 more failures is what this ends up doing. And so this moves the sample proportion a little closer to 0.5. And so it makes the standard error a little bit smaller. And so now we're getting the 2 values that we saw in our credible interval and in our one group proportion from the ESCI module. Okay, so if we scroll down, there are actually 5 of these. There's a Kluper-Pearson, there's a Wilson score, and then we have the Agresti-Coull interval. And the beauty of it is, again, we do that +2 and then +4 to the sample size, and this is for our 95% confidence interval. What this does is it actually gets us closer to the 95% of all confidence intervals that we construct contain the actual population proportion. So it's a much better interval. So that's why the ESCI uses it. That's why the credible interval is there. Okay, so now that we've talked about that, we can go back and I can give you the final interpretation. Okay, so here's our conclusion. We are 95% confident that the true proportion of missions that Mr. Rory heatwave is helpful on is between the 0.481 and 0.741 using an Agresti-Coull method. If we're using the standard method, again, it is going to be a little bit different, but the only way to do it in Jamovi is using that Agresti-Coull method and the credible intervals. I hope that was helpful to you in using Jamovi and thinking about confidence intervals. If it was, that makes me happy.